Hello dear students. In previous lecture we have started friction. Now in previous lecture we have seen 5 numericals on friction, that is previous year gate numericals. In this lecture again we are going to see more numericals on friction topic which were asked in gate examination. Now here the first question which was asked for 2 marks in gate 2005 is on your screen. Now concentrate on the question. Two books of mass 1 kg each, right? There are two books and each book is having mass 1 kg, are kept on table one over the other. See here, in given data they are provided, there is a table. Let us say this is a table, right? On this table there are two books kept one over the other. Means if I see on this table there are two books of mass 1 kg each. Let us say the bottom book is number 1 and upper book is book number 2, right? And they are kept on the table, each having mass 1 kg. This M1 is 1 kg. Let us say M1 is 1 kg and M2 is also 1 kg. M1 is equal to M2 is equal to 1 kg. This is the given data, right? Now, again, the coefficient of friction on every pair of contacting surface is 0.3. Now here, the coefficient of friction mu is given 0.3 on every pair of contacting surface. Now look at the contacting surfaces. Can you imagine here between book 1 and table? There is one contacting surface. There is one contacting surface, right? Let us say this is a surface 1. Let us say this is a surface 1. For surface 1, I am writing S1. This is a surface 1 which is in contact, right? Again, between book 1 and book 2, there is one more contacting surface. There is one more contacting surface. And for this surface, I am writing S2, surface 2, contacting surface 2, S2, right? Means there are two contacting surface, and for each contacting surface, coefficient of friction is 0.3. On each contacting surface, coefficient of friction is 0.3. This is a given data. The lower book is pulled with horizontal force F. Now, the lower book, this book 1 is pulled with horizontal force F. Let us say I am applying horizontal force F towards right, pulled with horizontal force F. The minimum value of F for which slip occurs between the two books is. Now, question is, what is the minimum value of this force F for which slip occurs between the two books, right? Now, for minimum value of force P, can I say slip just begin or just start of motion? Just start of motion of lower book, right? That is book 1. Means here just start of motion means it is a limiting friction. It is a case of limiting friction. Whenever it is just start of motion, it is a case of limiting friction. That is friction force is equal to mu times normal reaction. That is friction force is equal to mu times normal reaction, right? Now again, for contacting surface, right? Whenever there is a contacting surface, there are two reactions on contacting surface. One is normal reaction. That is N, which is perpendicular to the surface. Normal is contacting surface, right? And one more, there is a friction force. There is a friction force FR, which is parallel to the surface. In the direction opposite to the relative motion, right? In the direction opposite to the relative motion. Now let us go for solution. Here I have understood one thing. It is a limiting friction condition. Therefore, friction force is equal to mu n. Here in this case, frictional force will be equal to mu n, right? And coefficient of friction is given 0.3. Mass of each book is 1 kg. And our target is to find this F minimum so that slip occurs between book 1 and book 2, right? Now we have written the given data. Here I am erasing the question. Now let us go for solution. Right now, let us draw the free body diagram of each book. Here I am drawing the free body diagram of book number 1. Here I am drawing the free body diagram of book number 1. Right. Let us say free body diagram. Right. For book 1, this is a book 1. Right. Have this is number 1 on which force F is acting towards right. Right. Now the mass of this book is 1 kg, which will act in vertically downward direction. Definitely. Right. Mass of book will definitely act in vertical downward direction. That is, let us say weight 1. Weight 1 is equal to m1g. m1g. Right. Now contacting surfaces. At the contacting surface, there is at every contacting surface there is normal reaction and friction force. See, lower surface is in contact with table. This is surface 1, and upper surface is in contact with upper book. This is surface 2. Right. Now for lower surface, there will be a normal reaction n1. N1 is a normal reaction of table and lower book. Right. Now can I say, because of this force F, the lower surface is trying to move. Because of this force F, the lower surface is trying to move towards right. This will be the motion direction, and friction is opposite to the motion. Therefore friction force will be opposite to this motion, that is Fr1. This is Fr1, which is nothing but mu times n1, normal reaction 1. Right. Again go for upper surface. Now this upper surface is in contact with upper book, and because of this upper book m2 of mass m2, the lower book is not going in upward direction. Therefore there is reaction in downward direction. Let us say normal reaction. Because of this upper book, there is normal reaction n2 in downward direction. Right, in downward direction on surface 2. As well as, can you imagine, the surface 2 is, because of force F, the surface 2 is moving towards right. This is the relative motion of surface 2 towards right. Therefore for surface 2 there will be a frictional force which will be towards left, which is nothing but Fr2, which is nothing but mu n2, mu times, for surface 2 na, mu times normal reaction on surface 2. Right. Now this is the free body diagram of lower book, that is book 1 of mass m1. Of mass m1 is equal to 1 kg. Right. Now draw the free body diagram of book 2. Draw the free body diagram of book 2. Let us say here book 2. This is a second book having mass m2 is equal to 1 kg. Again same mass for book 2 also. Right. m2 is equal to 1 kg. Right. Now on this upper book 2, this is a surface 2. This is surface 2 which is in contact with lower book. Now for surface there is a normal reaction and friction force. Now as per Newton's third law, there is action reaction pair. There is always action reaction pair. That means the action on surface 2 is n2 downward and mu n2 right side, left side, sorry. See, book 1, n2 is downward. Therefore on book 2, n2 will be upward. Action reaction pair. As per Newton's third law, it is an action reaction pair. For this n2 downward, there will be n2 upward on book 2, and for this mu n2 towards left, there will be mu n2 towards right. This is an action reaction pair. This is called action reaction pair. As well as the self weight of this book acts in downward direction, which is W2. W2 is self weight of this book, which is nothing but m2g. Right, always acting in vertically downward direction. Now this is a free body diagram for book 1 and book 2. Now let us solve the question. Now here I am solving the question. Right. Now for equilibrium of book 2, right, can I write summation of forces along y direction is equal to 0? This is the equilibrium equation for book 2. Therefore downward, that is downward is minus W2, downward is negative, upward is positive, plus n2 is equal to 0. There are two forces only on book 2. W2 is downward, n2 is upward, upward is positive, downward is negative. Therefore equilibrium equation becomes minus m2g plus n2 is equal to 0. Therefore from this n2 is equal to m2g, which is nothing but mass 2 is 1 kg, acceleration due to gravity is 9.81. which is nothing but 9.81 Newton. Right. This is a normal reaction on N2. This is the normal reaction on second surface. N2 is 9.81 Newton. Now, similarly, can I write for equilibrium of book 1? For equilibrium of book 1, summation of forces along y direction is equal to 0. ये equilibrium equation होगा book 1 का, right? Summation of forces along y direction is equal to 0, right? Now, therefore, write down. See, W1 is downward, N2 is downward, and N1 is upward. Upward is positive, downward is negative. Therefore, plus N1 minus W1 minus N2 is equal to 0. Therefore, N1 is equal to W1 is M1G. उस साइड चला गया तो पॉजिटिव बन जाएगा. W1 is M1G plus N2, right? Therefore, calculate N1 from here. Calculate N1, my dear students. Therefore, N1 is equal to mass 1 is 1 kg, acceleration due to gravity is 9.81 plus N2 is 9.81, which is nothing but N1 will be equal to 9.81 plus 9.81, right? 9.81 plus 9.81. What will be the answer? Tell me. What the answer? 9.81 plus 9.81. Calculate and tell me your answer. Right. It will be 19.62 Newton. Now I have calculated N1, sorry. I have calculated here N1. Right. Now, but target is to find minimum force EF. Target is to find this minimum force EF. Right. EF. Now, for equilibrium again, for equilibrium of book 1 along x-axis. See here, I am writing the equilibrium equation again. For equilibrium of book 1, can I write summation of forces along x direction is equal to 0? Summation of forces along x direction is equal to 0. Now, as per this equation, right side positive, left side negative. Right side is force EF, left side is friction force 1, friction force 2. Therefore, can I write plus EF minus mu N1 minus mu N2 is equal to 0. Therefore, force EF is equal to mu N1 plus N2. Now put the values. Therefore, force EF is equal to coefficient of friction is 0.3 given. Coefficient of friction is given 0.3. Right. N1 we have calculated 19.62, and N2 9.81. N2 is 9.81. And if I solve this for EF, let us solve this and tell me answer for EF by putting all these value. You will find answer equal to 8.83 Newton. You will find this answer. Right. Means for your question, the answer is 8.83 Newton. Therefore, option D is correct choice. Here, option D is correct choice. You calculate your answer and comment me in comment box. Whatever may be your answer, comment me. Right. Okay, note down this. If you have any doubt in this question, you can ask me. If you have any doubt in this question, you can ask me. This was the 2-mark question. Right. Now, if you don't have any doubt, we will go for next question. किसी को कोई डाउट होगा तो मुझे पूछो, आप कमेंट में टाइप करके मुझे पूछ सकते हो. Okay, let us go for next question. Next question is on your screen. Now, this question was asked in GATE 2004 for 2 marks. Again, this is a very good quality question. Again, this is very, very good quality question. GATE 2004 for 2 marks. Right. Now come to the question. Okay, everyone is with me. मेरे साथ चलो, मेरे साथ क्वेश्चन को रीड करो. देखो क्वेश्चन अभी. The figure shows a pair of pin jointed gripper tongue holding an object weighing 2000 Newton. Right. See here. See, this is a pin jointed gripper tongue. This is a pin jointed gripper tongue. And this gripper tongue is holding an object of 2000 Newton here. Right. It is similar to the device in your home. This device you are using in your home. In Hindi or in any other language, you are saying it as a pakkad, right? For holding the utensils. जो भी आपके बर्तन होते हैं उनको पकड़ने के लिए आप पकड़ यूज करते हो ना, बस वही डिवाइस है ये, राइट? इट इज कॉल्ड ग्रिपर टंग, राइट? नाउ here on this grip, here there is a pin joint, here there is a pin joint, right? Now come to the question. The coefficient of friction mu at the gripping surface is 0.1. Now at these surfaces of contact, gripping surfaces, at these gripping surfaces, coefficient of friction is 0.1, right? Because of this friction only we can hold the object. Now xx is a line of action of input force. Here xx, here xx location is given. Here you are applying input force, means this position you are holding in your hand. पकड़ को इमेजिन करो, घर में जो आप बर्तन पकड़ने के लिए पकड़ यूज करते हो उसको इमेजिन करो. Here we are holding in hand, this location we are holding in hand and we are placing this so that input we can apply input force, right? Gripping force. If the pin joint is assumed to be frictionless, this pin joint is assumed to be frictionless, the magnitude of force F required to hold the weight is. Now, what is the magnitude of this force F so that this force F will hold the weight of 2000 Newton, will hold the weight of 2000 Newton. This is the question here, right? Now, let us go for solution. Let us go for solution, right? Now, carefully understand these things. Carefully understand. I am here erasing the question and writing the given data. Coefficient of friction is, this question was asked in GATE 2004. Now, given data is mu is equal to 0.1. And what is force F? What is force F? So that there is no slip, right? Now, here I am erasing the question. Let us solve this question. Try to imagine this question, my dear students. आपके घर में बर्तन पकड़ने के लिए जो पकड़ रहता है वही है ये. Try to imagine this thing, right? Now options are given. A, B, C, D options are given, right? Now here again I am erasing the options also. Force F is to be calculated. Coefficient of friction is given. Okay. Let us solve this question. Very good quality question. Very good quality question. Now see, if I apply force F here with coefficient of friction 0.1, right? What is force F as this question? Let us concentrate on the weight. Let us concentrate on this weight. See, because of its weight of 2000 Newton, the block is trying to move in downward direction. Definitely, the block is trying to move in downward direction because of weight 2000 Newton. Let us draw the free body diagram of this block. Let us draw the free body diagram of this block, right? If I draw a free body diagram of this block, let us say this is a block having weight 2000 Newton. The weight is acting in downward direction. Weight is equal to 2000 Newton acting in downward direction. Now see, here there is one surface of contact. Here there is one surface of contact and another surface of contact. Let us say here it is surface 1 of contact. This side surface 1 and this side surface 2, S2, right? Means this side surface is surface 1 which is in contact. This is a S1 and this side surface is S2 which is in contact. Now for contacting surface there is always normal reaction. Means on surface 1 there will be normal reaction N1. On surface 1 there will be normal reaction N1 and surface 1 is trying to move in downward direction because of self weight. This is the motion of surface 1. Therefore there will be a frictional force which is opposite to the motion. Therefore frictional force which is mu N1 in the direction opposite to the motion, right? Now again for surface 2, can I say for surface 2 there will be normal reaction N2. There will be normal reaction N2, right? And this surface 2 is also trying to move in downward direction because of self weight. But for this motion, friction force will oppose. Therefore, there will be mu N2 in upward direction. There will be mu N2 in upward direction, right? This is the free body diagram of block. This is the free body diagram of block. Now, if I draw free body diagram of any one arm of this device, that is gripper tongue. If I draw free body diagram of any one arm of this gripper tongue, let us draw the free body diagram of this arm. This arm, right? Let us say I am drawing free body diagram for this arm, right? This one arm, right? Now see, for this arm, here this surface is in contact with surface 1. This surface is in contact with surface 1, right? And here it is force F is applied. Here force F is applied over this arm, right? Now I am drawing the free body diagram of this arm, right? Let us go for the free body diagram. If I draw free body diagram of this arm, right? Try to imagine the arrangement. Try to imagine the arrangement. Now, 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 see, this is the arm. Here I am drawing the arm, another arm, right? With this arrangement, right? Here force F is applied. Here force F is applied like this, right? And at pin, there is a pin. At this location, there is a pin joint. There is a pin joint, and from this pin joint, this force is at distance 300 mm upward, right? Now here surface 1, this is surface 1. Can I say this is the surface 1 for this arm? Now therefore for this surface 1, there is an action reaction pair. There is an action reaction pair for the surface 1. Now on surface 1 of the block, normal reaction N1 is going towards right. Therefore here normal reaction will go towards left. Normal reaction N1 will go towards left, right? Now there, and friction will go downward, but our target is not to understand friction. Don't worry about friction here, right? Friction will go downward definitely. Now this normal reaction N1 is at distance 150 mm, right? Now let us go for the solution now. Now our target is to find EF. Can I erase now here diagram? Here I am erasing the diagram. Okay, the actual diagram I am erasing here. Let us go for the solution now. For block 1, let us say block 1 is figure 1. Right? This is a figure 1. Here figure 1, and this is a figure 2. Here it is a figure 2. Now for equilibrium of figure 1, can I write for equilibrium of figure 1? That means block. Summation of forces along x direction is equal to 0. Therefore here, see, N1 is towards right, N2 is towards left. Therefore, plus N1, right side force is positive, left side force is negative, minus N2 is equal to 0. That means N1 is equal to N2 is equal to N. Means there will be same normal reaction on both surfaces. This I have understood from this equilibrium equation. Again, can I write for equilibrium of this figure 1, summation of force y direction is equal to 0. This is another equilibrium equation, right? Therefore, downward force is negative, upward force is positive. Therefore, downward is minus W, upward is plus mu N1 plus mu N2 is equal to 0. From this, can I write W is equal to mu N1 plus N2? W को उस साइड लेके चलो, पॉजिटिव बनेगा ना. W एक साइड पे पॉजिटिव, mu N1 mu N2 पॉजिटिव वन साइड पे, राइट? तो सॉल्व दिस क्वेश्चन, सॉल्व दिस इक्वेशन. Therefore, W is given. W is equal to mu N1 plus N2, and N1 is equal to N2 is equal to N. This we have already proven. Right? This is proven thing, right? Therefore, mu N plus N is equal to 2 mu N. Therefore, normal reaction is equal to W divided by 2 mu. Can I write? Normal reaction is equal to W divided by 2 mu, and weight is 2000. 2 into mu, coefficient of friction is 0.1, and solve for this. You will find the answer is equal to 10,000 Newton. Now I have calculated normal reaction, which is 10,000 Newton. But question is to not find normal reaction, my dear students. Question is to find EF. Here I have calculated only normal reaction, but question is to find force EF. Right. Therefore, let us go for the free body diagram of figure 2. I am erasing figure 1 because not necessary now. Now let us apply free body diagram for figure 2. For equilibrium of figure 2, can I write for equilibrium of figure 2, summation of moment about pin is equal to 0. Summation of moment about pin must be equal to 0. अब यहाँ पे कोई पूछ सकता है सर फोर्स इक्विलिब्रियम क्यों नहीं यूज किया? My dear students, at pin joint there will be a reactions. At pin joint there are always reactions in vertical direction and in horizontal direction, right or wrong? Therefore यहाँ पे हमने pin पे जो horizontal reaction Rx and vertical reaction Ry, we are not considering ना. Now जैसे कि हमने रिएक्शन कंसीडर नहीं किया है इसलिए मैंने मोमेंट इक्विलिब्रियम इक्वेशन यूज किया, बिकॉज द Rx and Ry are not creating, these Rx and Ry are not creating moment about pin, right? And as I am ignoring these reactions, hence I am using equilibrium equation as a moment equation. Therefore summation of moment about pin is equal to 0. Now for clockwise moment we have to consider positive, for anti-clockwise moment we have to consider negative, right? Let us assume, let us consider here, see force F, this force F is creating in clockwise direction about pin. Therefore the force F is creating anti-clockwise direction. Force F is creating anti-clockwise direction. Normal reaction N1 is creating clockwise direction, right? Therefore F anti-clockwise direction minus F into at distance 300 plus N1 into distance at 150 is equal to 0, right? Therefore from this can we write N1 into 150 is equal to F into 300, right? And N1 is nothing but N. N1 is nothing but N. N1 is equal to N2 is equal to N. This already we have proven. Therefore 10,000 into 150 divided by 300 is equal to F. And solve for this, you will get F is equal to 5,000 Newton. You will get F is equal to 5,000 Newton. This is the gripping force required, and this is your answer. And अगर option देखे आपने, option D is correct choice. From options, option D is 5,000 Newton, which is correct choice, right? Therefore for this question option D is correct choice. Okay, note down this. If anybody having any question, you can ask me. If you have doubt, write your doubt in comment box and comment your doubt. Okay, जैसे कि कोई किसी का डाउट नहीं है कोई, let us go for next question. I hope you are understanding all the things properly. Okay, Omkar, let us go for next question then. Let us go for next question. Okay, now next question is in a band brake. Now band brake, it is a question of pulley friction, belt and pulley friction. It is a question of belt and pulley friction. Now next three numericals we are going to see for belt and pulley friction, right? So let us understand the concept of belt and pulley first. Let us understand the concept of belt and pulley friction first, right? Now here I am writing belt and pulley friction, belt and pulley friction, very important concept, right? Now let us consider there is a pulley. Let us consider, if I consider one pulley, let us say this is a pulley, right? Now on this pulley a band is wound. Let us say the center of this pulley is here, center of pulley, and radius of pulley is R. Let us consider the radius of pulley is R. Here I am considering radius of pulley as R. Now on this pulley a band is wound, band or rope or wire. You can say band, or you can say a rope, or we can say a wire. Let us say here I am wounding the wire like this. Let us say this is a wire wound on the having very negligible thickness. Right? This is a, we can say band, it is a band, or we can say it is a rope, or we can say it is a wire, right? Now this wire or band or rope is wound over the pulley, Now let us say the coefficient of contacting surface. Here the coefficient of friction between this band and pulley, here it is a pulley, here it is a pulley. Now coefficient of friction between band and pulley is mu. At contacting surface over here, mu is coefficient of friction. See, this is a contacting surface, between them, and for this contacting surface let us say coefficient of friction is mu. Now let us say contacting angle. See here from this point with radius, from this point until this point, there is a contact between band or rope or wire and pulley. There is a contact between rope and pulley up to this point. Let us say this contacting angle is theta. Let us say this contacting angle is theta. Now theta is called angle of contact. Angle of contact between band and pulley or rope and pulley. Right. Now again it is called angle of lap. Angle of lap. Also sometimes it is called angle of wrap. Angle of wrap or wrap angle or lap angle. Sometimes this is the nomenclature. And always this theta we have to consider in radian in this topic. In radian, the unit of this theta is radian. Right. Now, in this pulley, if friction is considered, if friction is ignored, if mu is zero, coefficient of friction is zero, that is friction is ignored, then tension will be same. Tension is same. If friction is ignored, then tension will be same in both sides, right? But if a friction is considered, let us say there is a friction, there is friction present between band and brake, then tension will be different in both sides. And let us say I am assuming there are different tensions. Let us say T1 is tight side tension. Tight side tension. T1 is tight side tension, right? And T2 is slack side tension. Slack is also called loose side. Slack is also called loose side tension. And always tight side tension must be more than slack side tension. T1 is always more than T2. This is the relation. Now, how to identify tight side and slack side? That I have to see. How to identify tight and slack side, that I have to see. Now consider this pulley is rotating in clockwise direction. My assumption is the pulley is rotating in clockwise direction. Let us say this is rotation clockwise. I am assuming clockwise rotation. Right. Now, my dear students, there will be a tension in the pulley. Let us say here there is a tension. Tension is always shown away from the device. Tension T, tension T. Tension is always shown away from the device. Tension T. There will be tension T. Right. Now, tell me, with the help of rotation, see, rotation is clockwise. Rotation is clockwise like this. Rotation is like this. Right. For such type of rotation, definitely, this must be T1, this must be T2, because this must be tight side. This must be tight side, and this must be loose side or slack side, because the motion is always in the direction of maximum loading. The motion will be always in the direction of maximum loading. See how T1 is creating torque. T1 into radius. This torque is clockwise. Because of tension T1, the torque is in clockwise direction, and because of T2, the torque is in anti-clockwise direction. Because of T2, the torque is in anti-clockwise direction, and the rotation of pulley is in clockwise. Means clockwise torque is more than anti-clockwise torque. Definitely. Therefore, the direction of rotation gives you tight side. Therefore, this will be the tight side. T1 will be the tight side. Right. Now here, this tight side tension divided by loose side tension, they are related with e to the power mu theta. This is the relation between tight side and loose side tension. This derivation you are going to see in theory lectures. Here only I am explaining you formula. Tight side tension divided by loose side tension is equal to e to the power mu theta, where this theta must be in radian. Theta must be in radian. This is very important. Exponential function. It is a exponential function. Gate में पूछा ये. Exponential function. Question asked in gate. What is the ratio? What is the function, or what is the ratio of tight side and loose side? And what is this function? It is an exponential function. Again, if I consider logarithm, consider ln on both sides. Therefore, can I write ln T1 divided by T2 is equal to mu theta, is equal to mu theta. Therefore, ratio of tight side and loose side is also called logarithmic function. It is also called logarithmic function. Therefore, ratio of tight side and loose side is exponential function as well as logarithmic function. Right. जो भी exponential होता है वो हमेशा logarithmic होता है. Right. Now theta is angle of contact. Now again जिस डायरेक्शन में रोटेशन हो रहा है वो टाइट साइड होगा. See the direction of rotation. Now direction of rotation is like this. Therefore this will be the tight side and this will be the loose side. Right. Now Now this T1 and T2 are related with T1 divided by T2 is equal to e to the power mu theta, that we have seen, right? Now this theta must be in radian, this also we have seen. Therefore what is one rotation? One rotation means 360 degree, which is nothing but 2 pi radian. One rotation means complete one rotation means 360 degree means 2 pi radian. Therefore 180 degree is equal to pi radian. 180 degree is equal to pi radian. Therefore can I say 1 degree is equal to pi by 180 radian? 1 degree is equal to pi by 180 radian. This is the unit conversion required in numericals. This is the unit conversion required in numericals. Again, what is the torque? What is the torque here? Can I say torque is equal to, see, T1 into tension 1 into radius, it is in clockwise direction, therefore it is positive, minus T2 into radius, which is in anti-clockwise direction, which is negative. Therefore torque will be here, torque is equal to T1 tight side tension minus loose side tension into radius, because many times they have asked a question to find torque also, right? Therefore torque is equal to tight side tension minus loose side tension into radius, right? And this torque is responsible for the rotation. Now after these concepts, let us go for the solution. Let us go for the three question solutions, right? Note down this quickly and go for the solution. Let us solve this question then. Now this question was asked in GATE 2003. This question was asked in GATE 2003 for 2 marks. Now question is, in a band break, the ratio of tight side of a band tension to the tension on slack side is 3. Means tight side tension, the ratio of tight side tension T1 to the slack side tension T2 is given 3. Right? It is given 3. Now again, if the angle of overlap means lap angle, angle of overlap means contact angle of a band and the drum is 180 degree, means theta is 180 degree. Theta is 180 degree, which is nothing but pi radian. We have seen just, which is nothing but pi radian, right? Then the coefficient of friction required between drum and band is, the coefficient of friction required between drum and band is mu is question mark. Very simple question, my dear students. Very simple question. Just now we have seen what is the relation between tight side tension and loose side tension. Look at here for the relation. What is the relation between tight side tension and loose side tension? T1 divided by T2 is equal to e to the power mu theta. This is the relation, right? Now here it is a relation, T1 divided by T2 is equal to e to the power mu theta. Use this relation in this question. Therefore, for this question, if I write relation, that is T1 divided by T2 is equal to e to the power mu theta, right? Now question to find coefficient of friction. Now consider exponential function. It is an exponential function. Now consider logarithmic function. Consider ln on both sides. Therefore ln T1 divided by T2 is equal to mu theta. Therefore from this can I write coefficient of friction is equal to ln of T1 divided by T2 divided by theta. Put the values. Therefore coefficient of friction is equal to ln of tight side tension divided by loose side tension is given 3. ln of 3 divided by theta is pi. Theta is pi. Now you have calculator. You have calculator. Put all the values in your calculator and comment me your answer. आपके पास options है. Solve in calculator and tell me what is your answer. Comment me, my dear students. What is your answer? Okay. If you solve this question, you will get answer is equal to 0.35. You will get answer is equal to 0.35, near about 0.35. Now this answer is option D. Is for this question your correct answer is option D. Option D is correct choice, right? Therefore select option D. अगर किसी का कोई other answer आ रहा है तो कमेंट में मुझे बताओ. And if you are getting same result, that is 0.35, then no worry. Okay, let us go for next question. If you have doubt, comment me. Otherwise, we will go for next question. Okay, चलो next question की तरफ चलते हैं. Now the next question is on our screen. Now this question was asked in GATE 2010. This question was asked for 2 marks in GATE 2010 for 2 marks. Right. Now let us solve this question. A band break having bandwidth 80 mm. Now, those who are civil students, don't worry about the band break word, because for your syllabus you don't have break design, but you have friction topic, and they will ask you the question on this. They can ask you question on this, right? And for mechanical students, they have brake design separately in their syllabus in machine design subject. So don't worry about this. Band brake is nothing but a belt and pulley friction. It is a belt and pulley friction. And the question is related to our GATE examination. That's why we are considering, or we are taking here. The band brake having bandwidth of 80 mm, drum diameter 250 mm. Here, the band brake is given having drum diameter of this drum, right, is this diameter is given diameter. This diameter is given 250 mm for drum, right? Means radius will be equal to 125 mm, right? Radius will be equal to 125 mm. Now, the coefficient of friction mu is given 0.25. See the given data. The coefficient of friction is 0.25, and angle of wrap is 270 degrees. Angle of wrap is 270 degrees. Means theta is equal to 270 degrees. Now, theta is equal to 270 degrees means how much radian? That is 1 by 180 into 270 into pi. This is the unit conversion or not? Pi by 180, we have to multiply with pi by 180, right? Therefore, theta will be equal to 3 pi by 2 radian. 270 degree means 3 pi by 2 radian, right? Means if one side is like this, let us say one side on the band is like this, then by rotating for 270 degree, the other side will go like this. The other side will go like this. Let us say this is a tight side T1, then this will be the loose side T2. And angle of contact with center. See, this angle of contact, this theta is 270 degree. This theta or angle of contact is 270 degree. Right. Now 270 degree required to exert a friction torque of 100 Newton meter. Now here torque is given, my dear students. Friction torque is given 1000 Newton meter. 1000 Newton meter. This is the friction torque given. Right. Now, question: the maximum tension in kilonewton developed in the band is. The question is to find maximum tension T1 in kilonewton. What will be the maximum tension in kilonewton? This is your question. Now let us go for solution. अगर किसी ने सॉल्व किया है तो आंसर बताओ मुझे. If someone has solved this question, tell me your answer. This question was asked in GATE 2010 for 2 marks. किसी ने क्वेश्चन सॉल्व किया है तो मुझे आंसर बता दो. What is your answer? Now let us solve. चलो हम सॉल्व करते हैं क्वेश्चन को. We will solve this question. Now see, what is torque? Torque is nothing but tight side tension minus loose side tension into radius. Torque is nothing but tight side tension into loose side tension into radius. Torque is given in Newton meter. Therefore, tensions will come in Newton and radius we have to use in meter. Tension will come in tension and radius we have to use in meter. Therefore, 1000 is equal to tight side tension T1 minus loose side tension T2 into radius. Radius is given 125 mm, which is nothing but radius is equal to 0.125 meter. We have to use in meter, right? Therefore, 0.125 meter. Therefore, from this T1 minus T2 is equal to 1000 divided by 0.125. And this will come, if you solve this, then T1 minus T2, this difference you will find 8000 Newton. T1 minus T2 is equal to 8000 Newton. This is the first equation. Newton. It is in Newton. This is the first equation. Now let us use another equation. That is tight side tension T1 divided by loose side tension T2 is equal to e to the power mu theta. Right. Therefore, tight side tension T1 is equal to loose side tension into e to the power. Coefficient of friction is given. What is the coefficient of friction given, my dear students? 0.25. And theta is 3 pi by 2. 3 pi by 2 into 3 pi by 2. See, coefficient of friction is 0.25. Theta is given 3 pi by 2. Now, if I solve here, then I will get T1 is equal to relation between T1 and T2. Solve this and comment me. T1 is equal to 3.248 T2. This is your second relation. This is your second relation. Now you have two relations and two unknown. You have two relations and two unknown. Put equation 2. Put equation 2 in equation 1. In equation 1. You have equation 1. Put this equation 1 and 2 in between. Right. अब यहाँ पे अगर मैंने equation 2 को equation 1 में put कर दिया. Let us put this. What is equation 1? Equation 1 is T1 minus T2 is equal to Newton. Therefore, T1 is nothing but 3.3.24, sorry, 3.248 T2 minus T2 is equal to 8,000 Newton. Therefore, 2.248 T2 is equal to 8,000 Newton. From this T2, I will get 8,000 divided by 2.248, which is nothing but, if you calculate T2, you will find 3558.7 Newton. This is the value of T2, my dear students. This is the value of T2, but they are asking what is T1. They are asking what is tight side tension, and put the relation. What is equation 2? Equation 2 is T1 is equal to 3.248 T2. This is the equation 2. Right, put the values. Therefore, T1 is equal to 3.248 into T2 is 3558.7. And therefore, T1 is equal to it. The answer will be in Newton, my dear students. My dear students, it is in Newton. Answer will be in Newton. Therefore, answer is 11.56 into 10 to the power 3 Newton. This is the T1. Now, but my dear students, as it is Newton, they are asking in kilonewton. They are asking in kilonewton. We have calculated here T1, which is nothing but 11.56 into 10 to the power 3 Newton. Therefore, T1 is equal to 11.56 kilonewton in kilonewton. Therefore, option D is correct choice. Here, for this question, option D is correct choice. Right. Omkar, yes, correct. Option D. Option D will be correct choice. Yes, correct. Okay. Let us go for next question. After solving this question, let us go for next question. Note down this quickly. अगर किसी ने नोट डाउन नहीं किया है, नोट डाउन कर रहा है तो रहने दो. This video will remain on YouTube forever. So let us solve next question with me. तभी तो पता चलेगा ना आपको कोई डाउट आ रहा है कि नहीं. अगर मेरे साथ क्वेश्चन सॉल्व करोगे तभी मुझे पता चलेगा आपको कोई डाउट आएगा या नहीं. ओके दिवेकर, चलो नेक्स्ट क्वेश्चन सॉल्व करो. फिर अब नेक्स्ट क्वेश्चन को सॉल्व करो. वेरी गुड क्वालिटी क्वेश्चन. In this question, you will find surface friction as well as belt and pulley friction. In this question, you will find surface friction as well as belt and pulley friction. Right. चलो मेरे साथ क्वेश्चन पे आ जाओ. अगर किसी का नोट डाउन करना बाकी है प्रीवियस क्वेश्चन का, तो यूट्यूब पे वीडियो रहने वाला है. मेरे साथ सॉल्व करो तभी तो आपको डाउट आएगा या नहीं पता चलेगा, और आएगा तो इमीडिएट मुझे पूछ सकते हो आप. चलो, नाउ नेक्स्ट क्वेश्चन इज ऑन स्क्रीन. The question is, calculate the value of self-weight P. Here, we have to find the value of self-weight P. Question is to find value of self-weight P. P is equal to question mark, right? Required so that motion impedes for 500 Newton block as shown in figure. See, understand the meaning. Motion impedes. Motion impedes means it is just a start of motion. It is a case of just start of motion. Just start of motion. Motion impedes means just start of motion. Means it is a limiting friction. It is called limiting friction. It is called limiting friction. Right. Means in this question they have provided you the concept. The concept of limiting friction means friction force. Friction force is equal to mu times normal reaction. Friction force is equal to mu times normal reaction. This concept you must understand. Right. Now again, let us go to the question. The coefficient of friction of all surfaces of contact is equal to 0.2. Now, for each and every contacting surface, coefficient of friction is given 0.2. Right. This is given data. Let us solve this question. Now, we have understood that motion motion impedance means just a start of motion. And coefficient of friction is given 0.2. Right. Here, mu is given 0.2 for each contacting surface. They are saying for each contacting surface. So let us solve this question. Now, first of all, identify the contacting surfaces. First of all, identify the contacting surface. Now see, for block of weight 500 Newton, for block of weight 500 Newton, there is one contacting surface, right? And as well as between the rope or band, between the rope and this pulley, between this wire and pulley, there is one contacting surface. And for each contacting surface, there is a friction. This is the question. Now, see, just try to imagine the diagram. Here, I am erasing the question. I am erasing the question. थोड़ा सा डायग्राम को देख के दोस्तों इमेजिन करने की कोशिश करो मोशन किस डायरेक्शन में होगा. Just try to imagine the direction of motion. See, because of this force P, the block is trying to move in downward direction. This block of weight P is trying to move in downward direction because of the gravity. And if this block moves in downward direction, definitely the wire on the pulley is rotating like this. This will be the motion for pulley, which is in clockwise direction. The motion of the pulley will be in clockwise direction, and 500 Newton block is direct moving towards right. This will be the motion for pulley. And this motion for pulley is directly moving towards right. This will be the motion for pulley. And this motion for pulley is directly moving towards right. This will be the motion for pulley. And this motion for pulley is directly moving towards right. This will be the motion for pulley. Okay. Now, here we have identified the direction of motions. Here we have identified the direction of motions. Let us solve this question. Now, Hello, my dear students. Sorry for the disturbance. Hello, my dear students. Sorry for the disturbance. Sorry for the disturbance. Am I audible? थोड़ा डिस्टर्बेंस आ गया था. हेलो हेलो, एम आई ऑडिबल नाउ? आवाज आ रहा है ना सबको? ओके, लेट अस गो फॉर द सॉल्यूशन देन. थोड़ा सा डिस्टर्बेंस आ गया था, सॉरी फॉर दैट. नाउ वी हैव आइडेंटिफाइड द टाइट साइड्स एंड लूज साइड एज वेल एज मोशन. नाउ लेट अस गो फॉर द फ्री बॉडी डायग्राम. Let us go for the free body diagram. Now if I draw free body diagram of block P, let us say if I draw free body diagram of block P, let us say this is a block P. Block P. The self weight definitely acts in downward direction, which is nothing but P, and there will be tension in the wire, which is T1, because already we have identified the tight side. Tight side is connected to block P, therefore tension is T1, and tension always we have to show away from the device. Tension always we have to show away from the device, right? Now, tension is always away from the device. Now, let us go for free body diagram of pulley. Let us go for free body diagram of pulley. Let us say this is a pulley, right? For pulley, tight side is going downward. This is a T1, and right side and towards left there is a loose side T2. Towards left there is a loose side T2, right? Now, because tight side and loose side we have identified, and tensions are always away from the device. And now let us understand the angle of contact. Let us understand the angle of contact. What is the angle of contact with the center? Can I say this is the theta? Angle of contact theta is nothing but here 90 degree, which is nothing but pi by 2 radian. 90 degree means pi by 2 radians in radian, right? Now again, if I draw free body diagram of this 500 Newton block, 500 Newton block here, my dear students, हमने यहाँ पे फ्रिक्शन कंसीडर किया है. Because of friction only there is a tight side and loose side. If we don't consider friction, then the tension on both sides will be same. Here we have considered the effect of tension, friction. Because of this only the tight side and loose side will come, and if friction is ignored, then tension on both sides will be same. So here we have considered the effect of friction also. Now let us go for free body diagram of 500 Newton block. Now this 500 Newton block is resting on one surface. On this surface is a 500 Newton block. Therefore, weight always acts in downward direction, that is 500 Newton. Now, for this surface in contact, see, also before this surface, see, this block is connected with loose side. This block, 500 Newton block is connected with loose side. Therefore, there will be a tension which is equal to T2. And away from the body, हमेशा टेंशन को दूर दिखाते हैं हम. इट इज ऑलवेज अवे फ्रॉम द फ्री बॉडी डायग्राम, राइट? टेंशन T2 as well as for this surface. Can you imagine, for this surface there will be one normal reaction. Let us say this is a normal reaction En, and motion is for this surface. On this surface the motion of block is towards right. On this surface the motion of this block is towards right. Therefore friction will be towards left. Friction is always opposing the motion, no? And it, as it is limiting case, therefore it is mu n. Friction equal to mu n, because it is a just start of motion. Therefore friction equal to mu n, mu times normal reaction. Now this is a free body diagram. Now let us name the free body diagrams. Let us say for this block free body diagram is figure 1. For belt and pulley free body diagram is figure 2. And for block P, free body diagram is figure 3. Now I have named here figures, right? Now let us apply the equilibrium equations for different figures. Let us apply equilibrium equations for different figures or different blocks. Now here I am applying first of all for figure 1 the equilibrium equation. Coefficient of friction mu is given 0.2. Coefficient of friction mu is given 0.3, no, 0.2, sorry, 0.2. And angle of contact theta is given pi by 2 radian. Pi by 2 radian. Now for equilibrium of figure 1, can I write equilibrium of figure 1? Can I write summation of forces in a y direction is equal to 0? Summation of forces in y direction is equal to 0. Upward is positive, downward is negative. Therefore, plus n minus 500 is equal to 0. Therefore, normal reaction n is equal to 500 Newton. Normal reaction n is equal to 500 Newton. Similarly, for figure 1, can I write summation of forces in x direction is equal to 0 for equilibrium? Summation of forces in x direction is equal to 0. Therefore, x direction towards right are positive, that is T2 is positive, towards left are negative, that is mu n is negative. Therefore, plus T2 minus mu n is equal to 0. Therefore, loose side tension T2 is equal to mu n. Therefore, T2 is equal to coefficient of friction is 0.2. Normal reaction is 500, which is nothing but T2 is equal to 100 Newton. T2 is equal to 100 Newton. All right. Now, again, write down equilibrium equation for this figure 2. If I write equilibrium equation for figure 2, let us say equilibrium of figure 2. Now, concentrate on figure 2. Can I say figure 2 is belt and pulley device? Wire and pulley device. For this figure 2, can I say the equilibrium equation is tight side tension divided by loose side tension is equal to e to the power mu theta. Right? Tight side tension divided by loose side tension is equal to e to the power mu theta. Therefore, T1 is equal to T2 into e to the power mu theta. Put the values. Therefore, T1 is equal to T2, we have calculated 100 into e to the power. Coefficient of friction is 0.2. Theta is pi by 2. Theta is pi by 2. And solve for T1, my dear students. Solve for T1 here. Tell me answer. What is your answer, T1? Tell me your answer. Solve for T1. I think the T1 will be 137 Newton. I think the T1 will be near about 137 Newton. This is the value of T1. Check your answer. My dear students, check your answer. Whatever may be the answer, check your answer and tell me whether I am correct or wrong. Now, and now we have calculated T1 is equal to 137 Newton. Again, write down equilibrium equation for figure 3. For equilibrium of figure 3. For equilibrium of figure 3. Can I write summation of forces along y direction is equal to 0? Now upward is positive. Therefore, here T1 is positive for figure 3 plus T1. And self-weight P is going in downward direction. Therefore, minus P is equal to 0. Therefore, P is equal to T1, which is nothing but 137 Newton. Therefore, the question is to find the force P, which is nothing but 137 Newton. Your answer is, for this question, your answer is 137 Newton. And they will ask you for fill in the blanks. And in fill in the blanks, you have to type 137. If it is in Newton, you have to type 137. Okay. Now, if you have any doubt, you can comment me. कोई doubt होगा तो मुझे पूछो. If any doubt, ask me, my dear students. Okay. No doubt. Now, okay, no doubt. Now, see, many times again in competitive exam, many times they have asked, the question is the ratio of tension on tight side, the ratio of tension on tight side to the tension on loose side is in a flat belt is. Options are, ये कौन सा फंक्शन है, ऐसे क्वेश्चन पूछा था. Options are proportional to product of coefficient of friction and lap angle. This T1 divided by T2 is proportional to product of coefficient of friction and lap angle. Option B, this exponential function. Option C, proportional to lap angle. T1 by T2 is proportional to lap angle. And option D, proportional to coefficient of friction. T1 divided by T2 is proportional to coefficient of friction. Right. These are the different options. Very simple. T1 divided by T2 is equal to e to the power mu theta. Means it is an exponential function or not? It is a exponential function. This function is called exponential function. Therefore, option B is correct choice. For this question, option B is correct choice. But my dear students, they have not provided exponential function as a choice. They have provided you logarithmic function. They have provided you another option, which is logarithmic function. Logarithmic function. In this case, see, T1 divided by T2 is equal to e to the power mu theta. If I consider logarithmic function on both sides, therefore ln of T1 divided by T2 is equal to mu theta. Means ln is log to the base e. Log to the base e. This is called ln. Means it is a logarithmic function. It is a logarithmic function. Right. Therefore, option B is correct. Means the function which is exponential, is always logarithmic. Is always logarithmic. Right. Remember this one thing. Right. Okay. अगर कोई डाउट होगा तो पूछो मुझसे, क्योंकि अभी लेक्चर को कंक्लूड करने जा रहा हूं मैं. वी आर गोइंग टू conclude this lecture. In next lecture we will see dynamic friction. In next lecture we are going to see dynamic friction. मतलब फ्रिक्शन के साथ मोशन होगा तो वहां पे इनर्शिया भी आएगा ना. न्यूटन सेकंड लॉ के हिसाब से, एज पर न्यूटन सेकंड लॉ, इफ देयर इज अ मोशन, फोर्स इज इक्वल टू मास इनटू एक्सेलरेशन. विद सम एक्सेलरेशन बॉडी इज मूविंग विद सम एक्सेलरेशन. सो नेक्स्ट लेक्चर में हम डायनेमिक फ्रिक्शन का कंसेप्ट देखने वाले हैं, जहां पे एक्सेलरेशन भी आएगा. राइट. नाउ if anybody having any doubt, ask me your doubts in for this particular lecture or for my previous lectures. If you have any doubt, ask me your doubts. Okay, thank you Sana. चलो, जैसे कि किसी को कोई डाउट नहीं है, we are going to conclude this lecture. चलो, बाय बाय. ओके ओके मैत्री. अगर मेरे प्रीवियस लेक्चर देखे नहीं है तो उनको सारे लेक्चर को अटेंड करो. ईकेडा ऐप डाउनलोड करके उसमें भी रिकॉर्डेड लेक्चर्स है, उनको भी देख लेना. ओके ओमकार, चलो बाय बाय. ओके ओके बाय बाय. ओके सना, ओके सजिया, चलो बाय. अँड्रॉइडचा आहे नाही ना माझ्या एकच आहे. अरे एकच आहे. हा ना मग हरवली माझं ते ये तू म्हणजे आहे माझ्याकडं. काय काय गटू गटू ये तू कुठे कुठे तो आता तळवडे काय झालं ये घरी ये कोण नाही पता म्हणजे कशाला पाहिजे थोडं तुला आता काय काय आता काय काय रात्री काय किती झाला येतो अँड्रॉइड म्हणून काय लागा तू ये टीटीएम टीटीएम काय अरे माझा माझा सब्जेक्ट नाही संपला सब्जेक्ट संपल्याशिवाय पैसे भेटत नाही मी रेकॉर्डिंग पूर्ण